All right, so we're in AP Calculus. Today's date is Thursday, November 12th, 2020. Yeah, spherical related rates. This is second of the 3 related rate problems. Once we are done with 4-9, we are done with the unit. So our second to last lesson as well for the unit. Our objective today is to do what, Andrea?
Solve related rate problems dealing with the volume of spheres.
There it is. So yesterday was circles, today is spheres, and then tomorrow is triangles, right triangles. So if you see lowercase r, we typically associate that with what? Anyone? R is radius. And I prefer metric, so centimeters, decimeters, meters. I'm just going to go simple meters. I'm just kind of making up a unit. But if we assume that the radius is in meters, what must r prime be? Kind of a review from Tuesday. What is the meaning? What are the units? Either one. Anyone? Say again?
Meter squared.
Not quite. Meter squared is like a is like area.
Was it meters per second?
Meters per second. Yeah, thank you, Chris. So we'll write down meters per second, which means that is how fast radius is increasing or decreasing. So we can call this the rate of the radius. What about capital S? Kind of related to that left-hand side, differentiating volume and surface area. What do you think S is going to be then? Fiona? Say it louder. There it is, yeah, surface area. Everyone write down surface area. Who can give me units for surface area? Keyword being area. Anyone? Andrea?
Meter squared.
Meter squared, exactly. And then S prime, we'll go to give that to Teflon. What is the meaning of S prime? There it is, rate of surface area. And Chris, what would be the units for S prime? Yeah, meters squared per second. And finally, V. Andrea, what's V? Volume. Fiona, what are our units for volume? Meters cubed. Finally, we have V prime. Chris, what's V prime? Rate of the volume. How fast is the volume increasing or decreasing? Which is a very practical value, right? V prime would be like, I turn my faucet on high or low. How much fluid is coming out? How much amount of things are coming out? And Teflon, our units for rate of volume are V prime. There it is. So you can use, I don't know why the C didn't get written. You can use units to figure out what it's talking about. Is it did it give you V? Did it give you V prime? What is given to you in the problem? So let's talk about the balloon problem. That's our example 1. And that's all I'm going to give you. We have no backside. The volume of a balloon of radius r is 4/3 pi r cubed. Notice that it gives you the formula. You only have to have 2 formulas memorized. You have to have, well, I guess 3 if you include circumference. You have to have area of a circle, circumference of a circle, and you need Pythagorean theorem, a squared plus b squared equals c squared, but that's tomorrow. Once you have those 3 memorized, everything else is given to you just like in this problem. Okay, so if the radius is expanding at a rate of 14 inches per minute, imperial units, gross. At what rate is the volume changing when the radius is in inches, or is 8 inches? So what is given to us? Obviously, a formula is given to us, but aside from that, what is this 14? What is that? Can you say it louder, please? I can't hear you through your mask, and this thing is super Third time's the charm, Fiona. R prime. Yeah, because it's talking about the radius, so it has to be either R or R prime, and it says rate, and it tells you inches per minute. It's units per time, so R prime, you can all write down, is 14. And is that a positive or a negative 14, Fiona? Positive, why? Yeah, expanding is a positive word. If it's shrinking, then that would be a negative. So we have to be careful with our signs, just judging off of the language of the problem. All right, I have this 8 number. What is that 8? What letters can we assign that? Just radius, yeah, so we can just say R equals 8. I mean, it tells us R is equal to 8, so it's kind of cheating. Radius is 8, R equals 8. And what are we trying to find? Someone aside from Fiona who just did the last two? Say a letter. Are we trying to find, so capital V? Is it V or V prime? Which one? Why? Yeah, it says rate. What is the rate? What rate is the volume? So V prime. And that's going to be equal to box. Again, you can use question mark. That's the thing that we're trying to find. So those are the 3 things that are given to us in our problem. Okay, well, we're given V. If we need to find V prime, that means I'm going to be taking the derivative of this capital V. So let's go ahead and do that. Chris, I haven't heard from you in a bit. V prime, try it out. Take the derivative of 4/3 pi r cubed, or yeah, to the power 3 cubed with respect to t, with respect to time. So not with respect to r.
Dude, I don't know.
Okay, well, it's powerhouse, right? I have to the power of 3. The 3 is going to come down in front. 3 comes down in front. So it's going to be 3, and then the 3s are going to cancel out. So you're left with 4. So I'll come back here and we'll say this is going to be equal to 4 pi still number, so 4 pi. What about r? R squared. And then don't forget about your dinner. What's the derivative of r? R prime.
Oh,
Yes. All right, so we have our derivative. And then we can start plugging in things because we have an r and we have an r prime. And then we'll get v prime. It's just a simple take derivative, plug and chug, and you're done. Andrea, tell us what to write out for our right-hand side now. 8 squared times 14. All right, keep pulling it down, Andrea. So 4 pi times 64 times 14. That's a lot of math happening here. You guys can always find this by hand if you wanted to. I'm going to go ahead and simplify it for everyone. It's 3,584 pi. But we're not done because I really need to include this for next year. What are our units? We need to be really careful with our units. 3,584 pi, what? Anyone? Good guess. That is the right type of unit in terms of volume per time, but we're talking about inches and minutes now. It is inches cubed per minute. And then we can box it. So my general advice for all of us is make sure that you're taking the derivative because it's calculus. You're probably going to be taking the derivative and start plugging in things until you find an answer. Cool. That's all I have for the notes.